Question number 19. The question is to find the following limits. We have a limit as x approaches 3, x squared minus x minus 6 over x squared minus 3x. So first thing we want to do is we want to substitute 3 for x. Okay, so numerator we have 3 squared minus 3 minus 6. That's 9 minus 3 minus 6 is equal to 0, right? Denominator 3 squared minus 3 times 3, that's also 9 minus 9, which is equal to 0. So if both the numerator and denominator is equal to 0, we want to simplify each numerator and denominator. So numerator, limit as x approaches 3, our numerator is, if we factor that, that's x minus 3, x plus 2, right? Denominator, x squared minus 3x. So we can factor out x minus 3. And x minus 3, these two factors cancels out, right? So that is equal to limit as x approaches 3. We have x plus 2 over x. Now substitute 3 for x. So that's going to be 3 plus 2 over 3, which is equal to 5 over 3. Question 27. Here we have limit as x approaches 5, square root of x minus 1 minus 2 over x minus 5. So first thing we have to do, we have to substitute 5 for x, right? So numerator, we have square root 5 minus 1 minus 2. That's a square root over 4, which is 2. So 2 minus 2 is equal to 0, right? What about our denominator? 5 minus 5, that is also equal to 0, right? Then we have to simplify this expression. Especially we have a square root here, right? So we're going to have to rationalize this expression. So we're going to multiply square root x minus 1, 2. Since we have negative here, we must have a positive here, right? Over square root x minus 1 plus 2. So that is equal to limit as x approaches 5. You know, square root x minus 1 square, right? We're using this formula right here. A minus b times a plus b is equal to a square minus b square, right? So this expression right here, a minus b times a plus b, that's going to be equal to a square. So square root x minus 1 square minus b square, 2 square. So we have square root x minus 1 square minus 2 square. Denominator, we have x minus 5 times all of this expression right here. Root x minus 1 plus 2. So far so good. So root x minus 1 square, that's just x minus 1, right? So x minus 1 minus 4, that is equal to x minus 5. So we have limit as x approaches 5, numerator x minus 5, denominator we have x minus 5 times square root, or with a parenthesis, x minus 1 plus 2, right? So we have same vector here, x minus 5, x minus 5. So we're going to cancel these two factors. Okay, so we have limit as x approaches 5, 1 over square root of x minus 1 plus 2. So substitute 5 for x. So that's going to be equal to 1 over square root 5 minus 1 plus 2. This is root 4, which is equal to, right? So 1 over 2 plus 2, that's 1 over 4. That's our answer. Question 32. We have limit as x approaches negative 2 from right hand side. Absolute value 3x plus 6 over x squared minus x minus 6. So remember, absolute value of x is equal to, if x is greater than 0 or equal to 0, then that is equal to just x, right? If x is greater than or equal to 0. And absolute value of x is negative x if x is less than 0, right? If x is a negative, this value is a negative value, we must have a negative here so that all of this expression is positive, right? Does that make sense? Here we have absolute value 3x plus 6. So let's simplify this. Absolute value 3x plus 6, that's actually 3 times x plus 2, right? So that is equal to, well, we can write 3 outside of absolute value. So 3 times absolute value x plus 2, right? And this absolute value x plus 2 can be written as 3 times x plus 2 if x plus 2 is greater than or equal to 0, right? Which means x is greater than equal to negative 2. Does that make sense? So if x is greater than or equal to negative 2, 3 times absolute value x plus 2 is just 3 times x plus 2. What if x is less than negative 2? That means this x plus 2 is negative, right? Let me just write it right here. If x plus 2 is negative, then x is less than negative 2, right? Then this value is negative. So we must have negative in front of this expression x plus 2, right? Because this is negative. So negative times negative gives us positive, right? Absolute value is always a positive value. Does that make sense? Okay, so we're going to rewrite this limit. Limit is equal to, as x approaches negative 2 from right hand side. So that's going to be equal to, we're going to separate this equation, 3 times x plus 2 over this expression right here. That's actually x minus 3, x plus 2 if we factor, right? So x minus 3 times x plus 2, right? X plus 2. If x is greater than negative 2, right? X cannot be equal to negative 2 because if x is equal to negative 2, our denominator will be equal to 0, right? So when x is greater than negative 2, we have this expression right here. This is equal to this, right? Okay, what if x is less than negative 2? Then we have negative 3 times x plus 2 over x minus 3, x plus 2, right? Here we have the same factors, x plus 2, x plus 2. Cancel them out, right? Okay, so we're trying to find limit as x approaches to negative 2 from right hand side. Right? If x is greater than negative 2, we have this function, right? Since x approaches negative 2 from right hand side, we have to substitute negative 2 in this function, right? Does that make sense? So that is equal to 3 over negative 2 minus 3, which gives us 3 over negative 5. So that's our answer. Question 35. We have limit as x approaches 4, x plus 4 over x squared minus 8x plus 16. So what I'm going to do is I'm going to substitute 4 for x in this expression right here. We have a 4 plus 4 in our numerator that is equal to 8, which is not equal to 0. Denominator, we have a 4 squared minus 8 times 4 plus 16. So that's 16 minus 32 plus 16, which is equal to 0, right? Okay, if the only denominator is equal to 0, that means we have a vertical asymptote at x equal 4, right? So let's simplify this expression right here. That is equal to limit as x approaches 4, numerator x plus 4, denominator, that's actually what? X minus 4 squared, perfect square, right? So we have vertical asymptote at x equal 4. Here, that's 4, x-axis, y-axis. So the function, this function value actually approaches either positive infinity or negative infinity as x approaches 4 from left hand side, right? Also, as x approaches 4 from right hand side, the function either approaches positive infinity or negative infinity, right? So we're gonna test this. Let x is equal to, let's say, as x approaches 4 from left hand side, let's say this value is 3.9. If x is 3.9, this value is 7.9, right? It's positive, right? Okay, here, denominator, 3.9 minus 4, that's negative 0.1, but it's a square. We have a square here. That's a positive also, right? Positive 0.01, right? Positive over positive is what? It's a positive. We don't have to find exact value of this when we substitute 3.9 for x. We don't need the exact value, okay? All we need is we have to know if it's a positive or a negative. That's what we have to know, okay? So as x approaches 4 from left hand side, this whole expression, whole value is positive. So it approaches positive infinity like that, right? What about from right hand side? Right hand side, let's substitute a little greater than 4. So 4.1, I guess. 4.1 for x. Okay, 4.1 plus 4, that's also positive, right? 4.1 minus 4, that's 0.1. 0.1 squared is also positive. Again, positive over positive, right? So that's positive. So from right hand side, the function approaches positive infinity. Like that, right? So from left hand side, the function approaches positive infinity. From right hand side, also the function approaches positive infinity. So the answer is what? Positive infinity. All right? Question number 39. We have limit as x approaches 0, 4x squared minus 2x over sine 2x. Well, there is a formula we must remember in the limits with the trigonometric functions. That's limit as x approaches 0, sine x over x is equal to 1, right? Or limit as x approaches 0, x over sine x, that's also equal to 1, right? So when this expression right here, this angle right here, and this expression right here, if these two expressions are equal to each other and these two expression approaches 0, then limit is equal to 1. Okay, we can also have limit as x approaches 0 sine some constant a times x over ax, that's also equal to 1. Okay, when these two expression is equal to each other, and if all of this expression approaches 0, then all of this approaches 1. Okay, that's formula we have to remember. So let's solve this question now. We have limit 4x squared minus 2x. So we're going to factor that. Limit as x approaches 0, that's going to be 2x times 2x minus 1, right? Over, we have a sine 2x. Look at this. This expression right here, this expression right here, they're equal to each other, right? So this limit, the limit as x approaches 0, this expression approaches 1, right? Using these formulas. Does that make sense? So let me rewrite this expression. That's a 2x over sine 2x times 2x minus 1, right? And this expression approaches 1. And we're going to substitute 0 for x. So that's going to be 1 times 2 times 0 minus 1. That's going to be equal to 1, right? Oh, I'm sorry, that's actually 1 times negative 1, right? So that's going to be negative 1. Question number 41. We have limit as x approaches 0, x squared over 1 minus cosine x. Okay, first thing that I'm going to do is I'm going to substitute 0 for x. So numerator will be equal to 0 squared, which is equal to 0, right? Denominator, that's going to be 1 minus cosine 0. Cosine 0 is equal to 1, right? So 1 minus 1, that's also 0, right? So we will have to transform this expression into another expression using trigonometric formula, trigonometric identities, right? So we're going to multiply 1 plus cosine x in the numerator and denominator. Then we will have limit as x approaches 0, x squared times 1 plus cosine x over 1 minus cosine times 1 plus cosine, that's 1 minus cosine squared, right? Okay, from trigonometric identity, we know that sine squared plus cosine squared is equal to 1, right? Then 1 minus cosine squared is equal to sine squared, right? So that is equal to limit as x approaches 0, 1 minus cosine squared, that's sine squared. And we have x squared, right? X squared times 1 plus cosine, so times 1 plus cosine x, right? We know that limit as x approaches 0, x over sine x, that is equal to 1, right? So this is going to be equal to limit as x approaches 0, x over sine x squared, right? Because it's x squared over sine squared times 1 plus cosine x, right? So the limit of this expression right here, x over sine x, that's 1. So 1 squared times 1 plus, substitute 0 for x. So cosine 0, right? That is equal to 1. So that's going to be 1 times 1 plus 1. The answer must be 2. Question number 45. We have a limit as x approaches infinity. 3x squared minus 5x plus 1 over 3 minus 4x squared. Right? Okay. If x approaches positive infinity or negative infinity, what we have to do is we look at the denominator and look for the term with the highest degree. What constant is degree 0? And here we have a negative 4x squared, right? Degree 2, right? So highest degree in this denominator is 2. Then what we have to do is we must divide the denominator and numerator by x squared. This term right here. Okay, let's try this. So that is equal to limit as x approaches infinity. Here we have 3x squared minus 5x plus 1 over x squared. And denominator we have 3 minus 4x squared. Divide this by x squared. Okay, so that's going to be equal to, as x approaches infinity, here x squared, 3x squared. 3x squared over x squared, that's a 3, right? So that's going to be equal to 3. And here, negative 5x over x squared, that's going to be negative 5 over x. So minus 5 over x. And here 1 over x squared. So plus 1 over x squared. Okay, let's look at denominator. 3 over x squared. So that's going to be 3 over x squared here. And we have a negative 4x squared over x squared. That's going to be negative 4, right? So minus 4 here. So as x approaches infinity, this term right here approaches 0, right? Because of 5 over infinity. If we have infinity in the denominator, that's going to be equal to 0. That approaches 0, right? Also, this one, 1 over infinity squared, that's 1 over infinity, right? So that approaches 0. This one also approaches 0, right? So that's going to be equal to, we have 3 minus 0 plus 0 over 0 minus 4. So the answer must be 3 over negative 4. Also, there is another way to find the limit as x approaches positive infinity or negative infinity. When both the numerator and denominator have the same degree, in this case we have degree 2, right? Then the answer is leading coefficient of numerator over leading coefficient of denominator, which is equal to 3 over negative 4. It is because this is a rational function, right? We have the same degree in numerator and denominator. Then we learned that the horizontal asymptote is 3 over negative 4, right? So graph of this has horizontal asymptote negative and negative 3 over 4, like that, right? So the graph approaches the negative 3 over 4 as x approaches infinity, right? Either from here to here or from here to here, right? So as x approaches infinity, all of this expression approaches horizontal asymptote, which is equal to 3 over negative 4. All right? Question 49. We have limit as x approaches negative infinity, 3 minus 4x over square root 2x squared plus x. Okay, let's look at our denominator. The highest term, highest degree is square root x squared. Square root x squared, that is equal to x to the power of 1, right? So highest degree in our denominator is x to the power of 1. So we're going to divide both the numerator and denominator by x to the power of 1. So let's do that. So that is equal to limit as x approaches negative infinity, and we have numerator 3 minus 4x divided by x and square root 2x squared plus x over x. And we're going to rewrite this x with a square root. But one thing that we have to be careful is that when we write x with a square root, it can be written as two different ways. Sometimes x can be written as a square root x squared. Sometimes it can be written as negative square root x squared. If x is a positive number, let's say this x is positive 2, then this x can be written as a square root x squared. Think about this. Square root 2 squared, that's going to be square root of 4, which is equal to 2, right? So if x is a positive, it is equal to square root x squared. But what if x is a negative number? Let's say x is negative 2. Then we have to have here negative square root x squared. Because if we don't have negative, then that's going to be square root negative 2 squared. You know, negative 2 squared is positive 4, right? So that is equal to positive 2. Do you guys see that? So we must have a negative here. Negative, right? So if x is a negative number, then x is equal to negative square root x squared. So we're going to rewrite this x with a negative x squared. Square root x squared. So far so good? Okay, so let's simplify this. So limit, we're going to rewrite this expression. That's 3 minus 4x over x. Here we have square root 2x squared plus x over x squared with a negative, right? So that is equal to limit as x approaches infinity, 3 over x minus 4x over x, that's minus 4, with a negative square root 2x squared over x squared, right? 2x squared over x squared, that's 2, plus x over x squared, that's going to be plus 1 over x, right? So as x approaches negative infinity, this expression approaches 0. 3 over infinity, that approaches 0, right? 1 over x, that approaches 0, right? 1 over negative infinity approaches 0. So that is equal to negative 4 over negative square root of 2, which is equal to positive 4 over square root of 2, right? If we rationalize this, multiply by root 2, square root of 2 here. So that's 4 root 2 over 2. That's going to be 2 root 2.